Hi, everybody. Welcome to SIGGRAPH 2020. And today we're going to be talking about optimization. Obviously, something that has come up massively over the last bit is virtual production and real-time production. And that means that you guys are going to be learning a whole bunch about video game paradigms and how to actually use that. We actually have a talk later today specifically on that and how to use video game paradigms in real-time production. But this specific talk is optimization. How do you optimize those assets? When do you do it? And how do you actually know what parts need to be optimized and why they need to be optimized? So I'm going to go ahead and share screens, but I can definitely tell you I am extremely excited to go ahead and give this speech as most of my career was devoted to optimizing assets. So once again, this is asset optimization, a holistic approach brought to you by ModTech Labs. So and let's move over. So give a little bit about me. My name's Tim Porter, CTO of ModTech Labs. I am a serial entrepreneur. I worked at, well, I guess CTO at Underminer Studios and Volumation. Underminer Studios did a considerable amount of work surrounding corporate engagements for XR and things like that. Went to Full Sail University. I have a Bachelor of Science in Computer Animation. Spent at this point in time almost 2 decades in games and movies. Worked at a number of major places, including like 2-Bit Circus. I did a lot of work at Gameloft and Real Networks, and I've done over 50 games at this point in time, and most of it as a technical artist. And so it's something that's very important to me to explain to people, you know, how do you actually do this stuff? How is this actually viable for everyone? So we, ModTech Labs is specifically a venture-backed company by both Sputnik ATX and Quantsite Futures. And me specifically, and through Mod, I'm an Intel Top Innovator over the last 3 years and got a City of Austin Top Innovation Award. And another thing that's not in here, and it should be, is that we do a lot of work with CTA, and I'm the chair of the XR division, and also doing a considerable amount in standards around individuals' limited mobility. And ModTech Labs as well is doing work surrounding inclusion in XR. And so some of that fun stuff coming up. Okay, so what is ModTech Labs, and you know what's kind of the core? We are 98% faster, and that's because we use a massive amount of servers, distributed processing, and systems, and different things like that. We have automated systems, like I talked about, where we have a large array of servers that go ahead and process all of these different assets. It's a very interesting clustering queuing system that we've created called CQ processing. We do universal output. Obviously, it's extremely important for you to be able to take these assets and use them wherever you want. We are also a very secure private cloud. So a lot of worries about doing AWS and data ingress and egress and things like that. Those are a thing of the past with using Mod, because we have our own servers. And those servers are in a DoD levels facility. And then as well, our data ingress and egress is actually done over 256-bit encryption. So very, very secure, very, very safe. So optimization, why bother? What do you want to do? Obviously, you want to do it early and often, but only sometimes. You have to really kind of pay attention. What we would do is do optimization at levels. You know, if you have a show tomorrow, you want to be as optimized as possible. But if you have a show down the way, you kind of want to leave it a little bit open. And the reason for doing that comes down to you don't want to over optimize something or spend a whole bunch of individuals' resources if everything's just not ready to go and you don't really know what is going to come next. So you need to make sure that you have your teams and individuals who are actually going to use this to go ahead and play with whatever assets that you have. It's very important that there's a big difference between looking at a profiler that says, you know, you're running at 5 frames per second. Oh, that's really bad, right? Maybe, maybe not. You would have to see it. It's more a perception thing. In many different cases where something appears that it will be bad, it may not be. Also remember that it's an iterative process. Don't do everything all the way to the nines in the very end. You know, like if you're going to do a major movie conversion where you're taking all of your assets that came from the LiDAR scans and massive, you kind of need some temp stuff, some stuff in there, start blocking, start setting it up. And then you can start bringing in assets a little at a time and start playing. Because one minor change could change you from being optimized and ready to go to like having absolutely no way to run in a very, very small amount of time. And then the other thing is always remember those optimizations that you go, well, that's just a little bit extra work. That's a little bit this, you know, it's good enough right now because, and this is inevitable, something will always happen where it's not good enough anymore. And then you'll need to optimize something. So always pay attention to what's the next level of low-hanging fruit. So it's kind of important. So once again, holistic approach. And why is this a holistic approach? So the comment that I always tell people is that it's basically like balancing a bowling ball on thumbtacks on a runaway train. But then on top of it, the train's on fire, I'm on fire, the bowling balls are on fire, and they're zombies. But you know, that doesn't really fit on a slide very well, but that's kind of how it works. You need to actually pay a lot of attention to different platforms and how different platforms are going to show. So if you are doing like a portal viewer using an iPad and it's sluggish and laggy, yeah, you know, I mean, yeah, you could optimize for that device, but I mean, you really kind of want to look at master. You want to look at where it's getting recorded to. If it looks good on master, you know, you kind of want to like save people's capabilities and use them in more relative fashion. So kind of learn where you're trying to do that and everything like that. Also learn the weaknesses of your pipelines. If you have an extremely manual, say, mesh creation process, but your optimization process is really fast, well, then, you know, it might be a really good idea to go ahead and start dealing with your mesh optimizer and making that a more prominent way that you run things through. When, you know, counteractively having a artist go back through and then remodel something may be a really dangerous proposition. So you kind of have to pay attention to how you process your pipelines and individuals and capabilities are able to do. And then also never expect that you're going to have a one-size-fit-all solution. So this is actually a really, really big thing. A lot of people will go ahead and go, I'm going to run everything on, you know, this optimization level. And that in some instances is actually good. But also remember that some assets, don't look very good being optimized to that level. Things like a human face can get away with a much lower optimization level than a human face with a body for some reason. It has to do with elbows and shoulders and joints. And we have these, you know, kind of body parts that really kind of get bizarre when you do levels of optimization to them. So you kind of have to pay a little bit of attention. And then also remember, mesh optimizing absolutely everything may not be the thing that you need to do. You may end up running into heavy LUTs when your materials are extremely high, so your textures are too high, so you have too many draw calls, and then you get back to this, and maybe the real issue was that you just needed to turn off, you know, a glow on a shader. You know, so it's kind of one of those things where it's this balancing act between all of the different angles and how you do that. So optimization textures, basically how much RAM does that texture take again? Very light amount. So you need to know the optimizations for whatever platform that you're working on. If you're going obviously high-end real-time movie capture, there's a bunch of different solutions where you know, you can get away with obviously much higher texture quality and fidelity, but just make sure you have things like LODs in there, you know, and even if it's not like a mesh LOD, you can get away with even texture LODs. It really does help out. You also want to know the weaknesses and the strengths of, once again, each of the different platforms that you're going to. The platform that you want to push everybody towards, and everyone's argument is, does it look good in final form? Does it look good in where we're recording to? If it looks good on an iPad and it doesn't look good in final form, well, you've really kind of screwed up, because in the end, what is really helpful as a development tool that doesn't end up showcasing for a client or end user, you've really kind of like, you have it backwards. And in the end, you're going to come out with just trash. And so it's really important to just kind of pay attention to where those boxes are. Optimization CPU, basically, how do you not set your CPU on fire? You want to go ahead and take a look to your dev team or whoever is actually doing the building. And Unreal blueprints can be extremely heavy and very unoptimized. And so when you're doing profiling and you notice really high CPU use, you might want to pay a lot of attention to whatever toolkit has been put in. One of the big things, having come from games, going to movies, and then back to games and entertainment again, is that movies, because things are built and they have a lot more time that things can get done. I mean, the idea that a frame in a movie can take, days is not something that could even dawn on a game developer. Now you're walking into game development paradigms. You have to have 60, 90, 120 frames per second, whatever you decide is buttery smooth, that comes out, and you're gonna have to pay a lot of attention to that. And so a lot of the skills that come from movie development and how scripts and automated tasks and tools are made don't transfer over very well. So you just have to pay a lot of attention to what those scripts and those things look like. Obviously, we talked about profiling, profile. Sometimes the last thing you want to do is, once again, live and die by the profiler. If it looks good and it runs good and the profiler says it's bad, well, objective versus subjective is, in some instances, a winning kind of situation. So you just need to go, well, if the director likes it, even if it runs slow, roll with it. It's the way it works. And then also know the limitations of your engine. Unreal provides a wonderful fidelity and feedback. Unity, on the other hand, has more issues when it comes to fidelity. Unreal, when it comes to playback quality and recording quality, being able to do everything all in one system, is at some limitations when it comes to actually being able to hit that frame rate and that target level and things like that based on shaders and whatnot. And Unity has an easier time with that. But if you're trying to get that super high end Unreal quality, you kind of have to play and, pay the piper. And so not always will adding more RAM, CPU, GPU will make things go better. You're just going to really have to see how the engine acts with it and what you can do to go ahead and optimize that. And then last one, of course, GPU magic. This one is GPUs are fun. Profiling GPUs can be extremely fun and can be extremely not fun. And so a lot of times when you're profiling a GPU, it may appear that your CPU is in fact the bottleneck, but the GPU is not feeding back the frames fast enough. And so you end up having a game where it is this overlapping kind of feature. And the other thing, and this is a very bizarre thing that people may or may not know, is that as you're going faster, so I'm going from 60 to 120 frames per second, the amount of time between each one of those frames gets quicker, right? That makes sense. But there is also a amount of data transport and transfer that ends up having to happen. So if you want to go up in the number of your frames, you're not just needing to go faster, you also need the amount of communication time to go down. So that means that you need a little extra buffer on top of it, because it ends up having to go from the CPU to the GPU over drivers, and those drivers end up having to talk to each other, and there is a certain amount of limitation of how fast those drivers can communicate. And it may not seem like a lot, but it really does add up as you go over time. Also, once again, pay attention. Effects are the things that make everything go slow. As much as we talk about, assets making things, and, that really, you want that shine, you want that sheen, you want the explosions and things like that. Those are the things that really hurt game engines. And that's the reason why when you play, games, the effects are, in a bubble, and people are smart about how they do that and how they deal with things. But you just need to really kind of be careful when all of those things go along. So hard drive optimization, this is something, if you're doing streaming caching, you're streaming from a drive and things like that, you really want to make sure that you have things either preloaded if you have a massive amount of RAM and the engine can handle it, or you get really good at streaming. And so this is something that we played a lot with. We played a lot with like volumetric video, and that was a major issue. So volumetric video, if you believe that you can have everything in RAM, you're crazy, because it just doesn't work. There's just way too much data. You end up having a single individual that could be, 8-10 gigs, and okay, let's go with 1, let's go with 4, you go with 8, and then you're using a 64 128 gigs just on the people that are in there instead of just the assets that are also streaming in. And then as well, if you have very large environments and you're having somebody walk through, or there's movement, or we're not just like in a single bubble and everybody's sitting here and all the backgrounds are all exactly the same, then you're going to have to stream. So you need to pay very close attention to how you're dealing with assets, how you're pre-caching them, how you are being intelligent about what is in the area that you're in. This is something that, you know, every game developer has worked on. You work in a what's called a 9-grid. You have this 9-grid pattern where it is you in the center, and then you have a checkerboard. It looks like you're playing checkers. I'm sorry, not checkers. You tic-tac-toe. You have a tic-tac-toe board. There you go. And then basically you want to, and it depends on how fast you're moving and everything like that. In the areas that this individual can walk in, you need to have those assets available in RAM around you. And then outside of that, you end up going to another level. So you end up doing a 9 board instead of just a regular, like it's a 9 on top of 9. So you end up having like another level of square that's around it. And then that ends up helping for your movement. But once again, you know, if you're going really, really, really fast, then you want to have even more that's on that. But that is how you get over hard drives, because as much as you know, an NVMe is fast and things like that, it still has to come from the drive over the PCI Express bus, and from there, then it ends up going into the RAM itself. And there are a lot of solutions that, you know, like Optane and things like that, that make it a lot better, but it still is what it is. And that's it. You know, that's kind of the holistic view. If you go to our website and you use the coupon code SIG20, we'll give you $500 worth of processing. And that's good for everything from photogrammetry to optimization to point cloud creation, and everything in between. And then once again, if you want to go ahead and email me, you have any more questions, comments, concerns, you want to watch me do an Irish jig, I've been working on it. It's really bad, but you know, I'm trying. You can email me at tim@modtechlabs.com. Once again, this is Tim from modtechlabs.com. Thank you very much.